Hello, my name is Mark Pimentel. I'm a CAM application specialist here at Hawkridge Systems, and in this video I'm going to show you how you can program for 5-axis trimming inside CAMWorks. So what we're looking at on screen here is a injection molded part or a thermoform part that I need to trim away from the flash or from any tabs holding it in place. And we're going to do that using the multi-axis mill operation using multi-surface features. I've already got the surfaces that I'm looking to use pre-selected for the purpose of the video, but otherwise you can make these as you go along. Surfaces I've selected are the surfaces to be trimmed, which are these side walls that represent the edges that I'm looking to trim. I've got the bottom faces of the part, the top faces of the part, and all faces. So what I'm going to do for my surfaces that I'm looking to trim, I'm going to go to Generate Operation Plan, and it generated my 5-axis strategy, the one from the TechDB. But I'm going to go and make some changes to that by double-clicking. Okay, and I'm going to go to my tool section here, and I'm just going to change the tool I'm using to this flat 1/4 inch. That should have the strength to do a full depth of cut and should be just large enough or small enough to fit in some of those corners there. If we go to the pattern section, in this operation I'm going to be using the method of milling, although you could use swarf milling, but I find that this one has the parameters I'm looking for. The pattern I'm looking to use is the offset from surface, and to find the surfaces I'm just going to pre-select my bottom faces there. The bottom faces only because I want to use the bottom edge of that side wall as the driving of my toolpath. I want my toolpath to just follow the trajectory dictated by the bottom edge there. So I've chosen the bottom faces, and I want that full depth of cut, so I'm going to set this to number of cuts 1. That way it'll just go right down to that line and follow that surface exactly. I do want it to start somewhere over here, so to make sure it does that, I'll add a start hint, and I'll click on this icon that allows me to choose the vertice of my start point. So now my trajectory, whatever I generate, should start right there. Under attracts entry/retract, I'm actually going to make sure I'm using a lead in, lead out at that point. So I'll use lead in, use lead out, and I'm going to define the lead in, lead out as orthogonal line. I find that this is the better way to do it because this will allow for a normal distance, for a linear distance that will allow for the cutter comp to engage. As a 5-axis toolpath, I need to make sure that I'm retracting away from the part no matter where I am on the part. So I'm going to set this to a plane in Z of 3. So you can see now that that has a nice clearance away from the part. If I go to gouch checking, as this thing tilts around doing the trimming, I'm going to be worried about maybe the holder colliding with the part. So I'm going to add a gouch check against the holder. I'm going to check against the feature surfaces, which are all those side walls, and just pretty much everything else on screen. So I'm just going to say all faces. Now, if there is a gouge, I'd like it to tilt the tool away from those surfaces, but not with the side tilt. The side tilt will tilt it away from the material completely. It'll tilt it actually in this direction. So I'm actually going to switch to use lead lag, which will tilt it in the direction of the cut. So if we take a look at our part in this direction, it's actually going to tilt this way. As it goes along this surface here to trim, it'll either lean into or lean away from the cut to avoid that gouge. This will be a cleaner way to do some of these edges, while still maintaining that side contact with the tool. If we jump to tool axis control, as a 5-axis operation, we need to control the angle of the tool, and I'm going to do that by using tilt relative to cutting direction. This will be tilted relative to the surface normal, so meaning that if I set this to 0, I'm using the bottom of the tool. If I set it to 90, I'm using the side of the tool. So that's what I'm looking for in my trimming. It's going to use a side tilt strategy of the ISO lines. So one way to get a feel for what those ISO lines are is if I just take this off screen. Without exiting out that window, I can go to Tools, Sketch Tools, Face Curves. Face Curves is a sketching command from SOLIDWORKS that allows you to create sketches based off of the mesh data of that surface. So if I just click on that surface, those blue and those pink lines represent the mesh lines, the ISO lines, and those pink lines, those would be what would be used if we were talking about the if we were looking at the ISO lines for control of the angle. And I don't really like how that's angled away from those curves there. I want my tool to follow those curves as my trajectory, and I want the angle to stay normal to those. So I'm not going to use the ISO lines. This is just one way to check those ISO lines to see if they're appropriate. So what I would do as a side tilt strategy is I'm just going to literally just tell it orthogonal to each position. So as it goes along that cut, the direction of the cut will be normal to that cut. So it's just a really simple way to keep the angle of the tool the way I like it. And then finally, in the finish section, I'll turn off adaptive cuts because we don't have any step overs or anything, so we don't need that here. And if there is any flash left over on the bottom, I just want to make sure I completely eliminate that. So I'm going to drop the tool a little further along the tool axis. I'll just put negative 30 thou there to account for any corner rad of my tool, or maybe just a non-sharp tool. Maybe there's just a kind of a rough end. This ensures that I'm using the complete side of the tool to trim out the part and removing any material on the very bottom. If there are any corners on this part that are not completely filleted, like this corner here, I'll turn on the blend radius and I'll just let it set to 0. That means it'll just give me that either sharp corner there, or I could change this value to a nice radius so I can smooth out that corner. This is more of a design consideration. You might want to actually go in there and add that fillet. It's a little easier for the 5-axis. So with all that created, I'm going to hit F5 on my keyboard and I'm just going to calculate the toolpath. Okay, so first thing you'll notice is that corner that I added the blending to became kind of a little bit of a step. That is because it's trying to account for the change of direction, change of tilt, but in a sharp corner. So that's one thing to note there. If we zoom out and we take a look at my part here, we can see I've got my lead in, lead out. We've got the drop in the tool direction, so all that is incorporated. What I want to do to make sure that this toolpath is correct is I'm going to check this corner to see if my gouge checking was engaged. So let's go into step through, and I'm just going to use the position slider here. We'll see that as it gets closer to the corner there, there's nothing in my 3D representation of my holder that's going to gouge there. And as we get a little further away from that corner, it also is not touching there. So we've got our gouge checking engaged correctly. It is going in a climbing direction. Everything looks good there. One other thing that I'd like to do in step through is click on this icon here that shows the tool vectors. Because in 5-axis, this could be the thing that causes the gouge. So if we make sure that all those yellow lines are away from the part, nothing's going in the negative direction, then that is correct. Looks good there. Click the green check mark. And one final thing, let's do a simulation on this. And you'll notice that the simulation is being done to a stock that looks the same as the original part. And I did that by design because I don't have anything that truly represents the stock, but I can use the same part as my stock definition so I can check for gouges. Because really I'm just going to be worried about gouging the original part. And I'll just slide this all the way to the right. Let's take a look at this in simulation. Everything looks like it's moving correctly. You'll notice on the side here I have a pause in the case of a gouge with the shank or the holder. So because I have that turned on, I'm just running this all the way through. I'm really just waiting for it to gouge, to pause, just giving me any warning that there's any issue. But so far, nothing's happening. Okay, and now that that's done, I'll zoom in on my 90-degree corner and I can just do a gouge check comparison. So if I did have anything representing stock, I would see that it maybe left a little bit of a fillet there. I don't have any gouge checks, so at minimum this looks good to me. So I'll just click the green check mark, click OK. I did a preview on that, so I don't necessarily have to regenerate, so I'm just going to say no. And the part is done. So 5-axis trimming, really simple. It is choosing the side wall that you like to trim and then putting in the parameters we saw here. Now if I want to repeat this, I can actually go to the feature section, feature tree, right click on my feature, and I can go to save operation plan, set it to new, and now I can save this as 5-axis trimming. And that way I can save those parameters for the future. So overall, this is a regular 5-axis operation, but with these parameters, it's dialing it in to becoming a 5-axis trimming operation. Any questions on this or anything else, just give us a call at the main tech line. If you like these videos, please like and subscribe to our YouTube channel. Thanks for watching.